Welcome to the DIY Honda Garage channel. The DTC P2DE1 indicates a cold start air-fuel ratio control system issue in the Honda Civic 2022 and newer models. This diagnostic trouble code signifies that the actual air-fuel ratio has exceeded the commanded levels, leading to a rich condition. A rich air-fuel mixture occurs when there is too much fuel or not enough air in the mixture, which can affect engine performance and emissions. The Engine Control Module, PCM, which is the vehicle's computer, monitors this ratio closely and triggers the DTC when it detects an abnormality. Components involved in this system include the mass airflow MAF sensor, the air-fuel AF sensor, fuel injectors, and other related parts that manage fuel and air intake. Understanding the role of each component, including their precise locations, is essential in troubleshooting the issue effectively. The DTC P2DE1 describes a scenario where the actual air-fuel ratio is richer than what is being commanded by the Engine Control Module, PCM. The PCM's primary function is to ensure that the engine operates efficiently by monitoring various inputs, including the air-fuel ratio. When it identifies that the actual ratio deviates from the expected levels, a fault is registered, and the P2DE1 code is stored. This rich fuel condition can be caused by several factors, such as malfunctioning sensors or fuel system components. Critical components related to this error include the mass airflow MAF sensor, which measures the amount of air entering the engine, and the air-fuel A-fuel sensor, which regulates the mixture. These components are crucial for the PCM to maintain optimal combustion and emissions levels. Several possible causes could lead to the DTC P2DE1 issue in the Honda Civic. A faulty air-fuel AF sensor may inaccurately report the air-fuel mixture to the PCM, thus triggering the rich condition. Additionally, leaking fuel injectors can introduce excess fuel into the combustion chamber, further skewing the air-fuel mixture. A malfunctioning mass airflow MAF sensor could incorrectly diagnose the air intake, leading to an improper fuel supply. Any issues with the evap canister purge valve or other fuel system components could also contribute to this rich condition. Understanding each component's role and potential failure points is essential to effectively diagnose the problem. The symptoms associated with DTC P2DE1 typically involve noticeable changes in engine performance and efficiency. Drivers may observe poor engine performance, often characterized by a lack of power during acceleration. Increased emissions may also occur due to the excessive fuel being burned, which can be detrimental to both the environment and vehicle compliance with regulations. Another common symptom is a rough idle. The engine may vibrate or shake more than usual when at a stop. These issues highlight the importance of addressing the underlying causes of DTC P2DE1 to maintain optimum vehicle functionality and compliance with emission standards. The first step in troubleshooting DTC P2DE1 involves turning the vehicle to the on mode without starting the engine. This prepares the vehicle for diagnostic checks. Next, it's critical to let the engine cool until the engine coolant temperature, ECT sensor 1, indicates a temperature of 77 degrees Fahrenheit or less. This step is crucial because performing diagnostics on a hot engine may lead to inaccurate readings. Once the temperature is verified, start the engine and allow it to idle for a minimum of 10 seconds. This idling period helps the PCM assess the current air-fuel ratio against its commanded values, providing data that can indicate the source of the issue. The second troubleshooting step requires a thorough inspection of various sensors and components linked to the air-fuel ratio control system. Begin with the mass airflow (MAF) and intake air temperature (IAT) sensors. These components directly impact the air entering the engine. Look for any signs of damage, disconnection, or incorrect installation that may affect their performance. Next, it's critical to check for any leaks in the fuel system, as even minor leaks can significantly alter the air-fuel mixture. Finally, examine the air-fuel AF sensor for proper functionality, ensuring that it accurately reports the air-fuel mixture back to the PCM for adjustment. Conducting these checks allows for isolating the faulty component contributing to the DTC. Once the necessary repairs are completed based on the troubleshooting steps, the final verification of the repair process begins. Start by clearing the diagnostic trouble code, DTC, from the PCM using a suitable diagnostic tool. This action resets the system and prepares it for a fresh assessment. Next, it is advisable to take the vehicle for a test drive under various conditions, including stops and accelerations, to ensure that the repair has resolved the initial issue. After completing the test drive, recheck the DTC status to confirm that no new faults have been registered. Successful completion of these steps will ensure that the vehicle operates optimally and will not trigger the P2DE1 diagnostic code again. Preventive maintenance is crucial to avoid recurring issues related to DTC P2DE1 and to keep the Honda Civic operating efficiently. Regular sensor checks are essential to ensure that the MAF and AF sensors are functioning correctly. If these sensors begin to malfunction, they can lead to improper air-fuel mixture readings. Additionally, conducting periodic fuel system cleaning can help maintain proper fuel delivery and prevent any clogging issues. Routine engine diagnostics should be performed to catch any potential issues before they evolve into larger problems. Incorporating these preventive measures can lead to a longer vehicle lifespan and improved overall performance. In conclusion, the DTC P2DE1 signifies a rich air-fuel condition that can significantly affect vehicle performance in the Honda Civic 2022 and newer models. Identifying the root causes, such as faulty sensors, leaking injectors, or MAF sensor issues, is crucial for prompt resolution. The troubleshooting steps outlined here provide a structured approach for accurately diagnosing and fixing the problem. Moreover, implementing preventive maintenance measures, including regular sensor inspections and fuel system maintenance, can help mitigate future risks of similar diagnostic trouble codes. Overall, staying ahead of potential issues will enhance vehicle efficiency and longevity. Please like and subscribe to the channel. See you next time.